Okay, so this is section 4.1, part 1. We're going to be talking about exponential functions here. Let's talk about what we've been talking about, which are our power functions. Most common one of which are polynomials. It's what we covered in the last chapter. And these are things like x squared, x to the fifth, x to the seventh, so forth. Notice here my variable is in the base. My exponent is a number. Now we're going to contrast this to where we're going to start here. And we're going to start on, these are what are called transcendental functions. So the exponential functions are in the form of some number like 2 to the x, 5 to the x, 7 to the x. So in these, your variable is the power and your base is a number. Okay, like in this one, my base is 2 and my exponent is x. In this one, my base is x, my exponent was 2. Okay, now the reason these fall in this range of transcendentals is because unlike polynomials, which have algebraic inverses, exponentials are one of these class of functions called transcendentals, which do not have algebraic functions. We'll talk about algebraic inverses. We'll talk about what they are a little later on. Okay, now our bases, so these are going to be some base to the x power. A has to be bigger than 0. It doesn't equal 1. Because 1 to any power is 1. It's kind of pointless. Okay, so the first thing you're going to have to do on these is evaluate them. So let's say I have a function, f of x equals 4 to the x. First thing I want to find is f of, you'll be given a series of points, so f of 0.5, which equals f of 1/2, which will equal to 4 to the 1/2, which is the square root of 4. You should remember this from rational exponents, which is plus or minus 2. Okay, so let's take a look at f of the square root of 2, which will equal to 4 to the square root of 2. You put that in your calculator, accurate to 3 decimal places, works out to be 7.103. Let's take a look at f of pi. That just equals to 4 to the pi. And you put that in your calculator, it works out to be 77.880 to 3 decimal places. Last one then will be f of 1/3, which will be 4 to the 1/3, which is the cube root of 4, which is approximately equal to 1.587. Again, to 3 decimal places. Okay, graphs. Okay, the parent functions of all these things are going to pass through one point. So I'm going to sketch a graph of 3 to the x and 1/3 to the x. Okay, now all of these points are going to go through the point 0, 1. All of our exponentials will go through 0, 1 unless we translate them. Okay, so it's going to go through 0, 1. The other point, I'll start with this one, is I'm going to pick is 1. So 3 to the 1 gives me 3. And that gets me enough to where I know this one is going to look like this. Okay, so 1/3 of the x, again, is going to go through 1, 1. 1/3 to the negative 1 is equal to 3, because it's 1 over 1/3, which is 3. So I know I want to go to negative 1. I'm going to come up to 3. And at 1, I'm going to be at 1/3. So this guy looks like this. And you notice a couple of things in common. First off, they both go through 0, 1. Now this is an increasing function, and this is a decreasing. We call this exponential growth, and we call this exponential decay. All right, the other thing you notice is they both have a horizontal asymptote at y equals 0. And this is also common to all of our exponential functions unless we translate them. Is they're going to go through this point and they're going to have a horizontal asymptote of y equals 0. Okay, so let's talk about transformations then. So let's go through, and my parent that I'm going to deal with will be f of x equals 4 to the x. Okay, so let's graph this guy. Now, I don't want to do 4 to the, yeah, I do want to do 4 to the x. Again, I know it's going to go through 0, 1. And at 1, it's going to go to 4. So this guy looks like this, and then it's going to come like that. So that's this guy. So now let's take a look at which will be 4 to the x plus 2. So this has been moved up 2 units. We talked about this in the first chapter, these transformations. And the same rules hold true for these transcendentals like exponentials. Okay, so what I do then is I just take my points here and I move them up 2 units. So 1 will go up to 6. All right. And my asymptote is also going to get moved up. And so that's the graph of this guy right here. All right. My asymptote then is going to be at y equals 2. Okay, let's deal with a different transformation then. Same parent. But now I want to deal with h of x is going to equal 4 to the x minus 2. And this has been shifted right. Remember, it's up inside of here 2 units. So this isn't hard to do. I take my original function here, which will be this guy. I'm going to move everything right 2 units. And so my 1, 4 will get moved excuse me, 0, 1 will get moved to 0, 0, 1 will get moved to 2, 1. I'm just moving it to the right 2 units. So that point goes there. This point, 1, 4, will go to 3, 4. And that's what this one looks like. I just moved this whole thing over. Now you notice my horizontal asymptote for horizontal shift is still at y equals 0. Some other common ones you might want to worry about are things like negative 4 to the x. This is reflected over y-axis. So if I have a negative, it's reflected over the x-axis. Negative 4 to the x is reflected over the x-axis. So now instead of this guy looking like this, I'm just going to reflect it over the x-axis, so it's going to come down like that. And 4 to the negative x, which would be the same as 1/4 to the x, which you should have recognized from what we did before, is reflected over the y-axis. So it would look like, it will still go through that one, but now at 1 I'm going to be at 4, so it's going to look like this. Okay, let's take a look at a couple more examples here. My parent is going to be 3 to the x. And this is part of what they're going to ask you to do, is to do these based on graphs of the parent function. So let's take a look at 3 to the x. So instead of actually putting it in your calculator, we're going to go back to my original parent. So I know I'm going to go through 0, 1, and then at 1, I'm going to be at 3. So here is my parent. Okay. We want to graph negative 3 to the x. Now we know with this negative in front of here, this reflects over the x-axis. So I just take all my points and reflect them over my x-axis. It's going to look like this. It should go through 3 instead of 4. So that's that one. Okay. And then let's graph another one. So now we want to graph 3 to the x minus 2. This is moved right 2 units. So again, the same thing, I'll go back to my parent. So 1, 1 now goes to 3, 1, and 1, 3 will go to 4, 3, and it will look like this. All right, so now let's talk about domain and range. One thing before I go on. Now, if you're just given a function, first thing, and you're trying to get it, first thing you want to do is see if it goes through 0, 1. If it does, then you can always get the base by going to 1 and looking at where it crosses the y-axis right there. This is assuming we haven't translated it, especially vertically, but even horizontally. So the first thing you want to do is check to make sure that it goes through 0, 1. And if it does, you go to 1 and you can get your base off of that. Okay, so let's take a look here at my parent function. Which was the black one. So domain, make up a table. So I'm going to have my function, and then domain and range. So if I have 3 to the x, if you take a look at this, you can see it covers all negative x values. It also covers all positive x values. So my domain is going to be all real numbers. And this is true of just about any exponential. My range, however, this thing approaches 0 but never gets there. So my range is going to be y is bigger than 0. So now let's take a look at the other one we did, which was the negative 3 to the x. We reflected over the x-axis. Again, my domain is all real numbers. But my range now is just the negative y values. We reflected it. So it's going to be y is less than 0, not equal to, because the y equals 0 is an asymptote. Okay, and then the last thing, again, let's take a look at 3 to the x minus 2, which is the green one right here that we shifted right. Again, my domain is all real numbers. And my range is going to be y is bigger than 0. Okay, so now let's take a look at what would happen then if I had taken 3 to the x So I've got 1, 3 and 0, 1. And I want to move it, let's do this a different color, up 2 units. So I'm looking at 3 to the x plus 2. So what I do is I take this point, I move it up 2 units. Take this point, I move it up 2 units. But I also take my horizontal asymptote and move it up 2 units. So now my function looks like this. And my domain and range of this is going to be a little bit different. So I'm going to have 3 to the x plus 2. So my domain now will be still all real numbers, but my range now is going to be only the y values that are bigger than 2. So your asymptotes on this one, take a look, my asymptote is going to be a y equals 0. My asymptote for this one is at y equals 0. My asymptote for this one is at y equals 0. My asymptote for this one is at y equals 2. And I hope you can see the pattern here.